Hi guys, so in this video we are going to discuss the decimal addition. So decimal addition, the key concept in that is to align the decimal point. So suppose we have two decimal numbers. The first is 2.3 and the second is 1.42. So how do we add that? So like I said, the key idea is to align the decimals. So we'll put the two numbers in a straight column. So we put, say, 2.3 at the top and 1.42 at the bottom. It doesn't really matter. You could have put 1.42 at the top as well. And then we just go and do the usual addition in a column form. So I'll assume that everybody knows how to add the numbers once in this format, but the key thing was that the decimal points are aligned. Okay, they're straight beneath each other. This is the important thing. Once you do that, you carry out the standard addition. So we get the answer 3.72. If we don't get the alignment correct, then everything goes wrong. So for instance, instead of trying to align on the decimal points, if we try to align from the right side, so 3 in 2.3 aligns with number 2 at the bottom. And then if we try to carry out addition, we can see it goes all wrong. The decimal points are not aligned. And if we still try to add the numbers, it turns out to be something like 1.6.5, which is ridiculous. So this is, the key takeaway there is that always align the decimal point. So if we understand the addition well, then we can carry out the subtraction in the same manner as well. So subtraction is the only thing that changes in subtraction is that there's a negative sign. So instead of adding, we subtract. But again, the key principle remains that we align the decimal and then subtract. So for instance, we have a number 2.3, 0, and then we have to take away 1.42. Again, the key thing, we must align the decimal, and then we carry out the usual subtraction. So the answer is 0.88. In terms of multiplication, things are not that bad either. So we just have to be a little careful. So in this case, we have the number 6.12, and we multiply it by another number 3.4. So we shouldn't get worried about that at, oh, how am I going to do this? If we know how to multiply the normal integer numbers, then decimal multiplication is not going to be much harder. So suppose we'll just pretend that this is a standard integer. So let's drop the decimal altogether for the time being. Pretend it's 612. Same is the case with the second number. So let's drop the decimal and just pretend it's 34. And we carry out our usual multiplication. So in this case, we multiplied the 612 at the top by the number 4 from among 34. And the answer is 2448. And then we carry out the multiplication for 3. So now we multiply 3 with 612, but also note a red 0 at the start. So we put a 0 at the bottom, and then multiply 612 by 3. And the answer is 1836. And there's a 0 at the end. And now we have two rows of numbers here. So we add those numbers together, and the answer is 20,808. So now what do we do? Obviously, 20,808 is not the final answer because we were not set out to multiply 612 by 34. Instead, we wanted to multiply 6.12 and 3.4. So how do we fix the answer? Well, count the digits behind decimal in both the numbers. What I mean is how many digits are on the right side of the decimal point in both the numbers put together. So in 6.12, there are 2 digits behind the decimal. And in 3.4, there is 1 digit behind the decimal. So altogether, there are 3 digits behind the decimal. So that means in 20,808, we'll start from the right side and put 3 digits behind the decimal figure. And therefore, the answer is 20.808. Okay, finally, division. So decimal division. So the principle is somewhat similar to multiplication, that we just try to get rid of the decimals. And once we get rid of the decimals, we are left with the usual numbers that we know how to divide. But in this case, we'll do slightly different thing. So how can we get rid of the decimals from the top of the fraction, which is the numerator 1.07, and the denominator, which is 0.007. So let's get rid of decimal. So how can we get rid of the decimal? We are going to multiply and divide by 10 repeatedly. What do we mean by repeated multiplication? Well, so we'll multiply by 10 in the numerator, and we repeat the same process in the denominator. And what do we get? We get 10.7 divided by 0.7. Now, 10.7 and 0.7 still have a decimal left in them. This is why I repeated the multiplication by 10 in the numerator and denominator. And therefore, we get 107 divided by 7. And then this is the normal integers that we do. And the answer is 15. Notice this is the final answer. So unlike multiplication, where we had to go back and count the number of digits behind the decimal, we don't have to do anything like that in terms of division. This is the final answer. So I hope that video is clear enough, and I hope you can practice with more examples there. Feel free to go back and look at the work done. Pause the video where you need and self-practice it, and revisit the video to match your answer with the work done in this video.